Good morning. What is that curvature called? When the plate is given, not the slab, the thickness has to be small and it is giving a curvature in one plane. Then it is called a shell. A shell. Then the structural actions are beam action, slab action, plate action, and a shell action. Shell is a three-dimensional arch. If you see an arch in the three-dimensional, along with its length also, then it is called as shell. Usually you have cylindrical shells. Cylindrical shells. If you see the traditional transportation systems drawn by bullock carts, there are movies where the hero and heroine or the people along with the hero and heroine will be traveling a long way in a bullock cart whose roof will be nothing but a cylindrical shell, usually bamboo. Bamboo will be the material. So it has a material character as bamboo and a fabricational character as a cylindrical shell, usually semicircular. So it will have some vertical bamboo for say around 1 meter. Then they will be connected by a semicircular bamboo shell roof. Shell roofs are very versatile in transferring the overburden. And shell roofs will be very thin in their cross section. A specific action of load transfer mechanism of shell is called the shell action. The shell will have curvature in both the planes. Now, in the cylindrical shell, it is having curvature only in one plane. The other is a linear element. If you see the longitudinal view of a shell, cylindrical shell, you will get only a rectangle, linear element. Only in the side view or the cross section, you can see the curvature. That positive curvature is called synclastic. That positive curvature is called synclastic shell. So cylindrical shell is a synclastic shell. It can have the curvature in the other direction also, in the y plane also. A negative curvature. For example, the saddle of a horse, That negative curvature, the concavity, is called anticlastic. So a doubly curved shell will have a synclastic curvature in one plane and an anticlastic curvature in the other plane. So doubly curved shells. Then there are very covetable, very attractive visual forms rendered by architects using these shell elements. So you will get shells of translation and shells of rotation. You will get shells either by translation or by rotation. Cylindrical shell. How will you get a cylindrical shell? Just have a circular arch, a semicircular arch. Then go on semicircular arch here, one semicircle on the other side. Just go on sliding a linear element, a line from bottom apex, that center point is called the crown of the arch, the crown of the shell. Go on sliding it down. It is a shell of translation. A cylindrical arch is a shell of translation. Whereas cone, you have a cone, you would have taken cone ice cream. It's not cone. That cone is a shell. It's a shell of rotation. You have an apex point. You just have. See this. If you just take this as an apex, go on revolving it. So you have a point element here. You have planar element circle here. You just rotate this element in such a way that it is gliding over this circle without shifting this point. Then you get a cone. Cylindrical element, you have a circle here. This is the circle. This is the, you go on taking like this. Similarly, there will be one circle here also. This is a linear element. You go on gliding over it, you get a cylindrical element. So cylindrical shell is a shell of translation and conical shell is a shell of rotation. You can have a combined shell of translation and shell of rotation. That is also possible. You will get hyperbolic paraboloid. Hyperbolic paraboloid. You would have seen the bamboo, using bamboo sticks, you have two circles. One circular element at the top, yet another circular element at the bottom. You just connect them in an inclined fashion. Or you just turn. You turn this circle in the clockwise direction, the top circle in the clockwise direction, and the bottom circle in the anti-clockwise direction. Just like that, you assume you get a shape. That shape is called hyperbolic paraboloid. It's a very complicated shape. It's not a developable surface. Cylindrical, you can develop. Cone, you can develop. But there are non-developable surface also used in the architectural designs. You have a stool using bamboo. Material is bamboo. You will have a hyperbolic paraboloid shell in which you can comfortably sit, having a cushion over it. There will be a facility for the cushion. There will be a depression on which you can put the circular cushion and you can sit comfortably. Then you need not have the cylinder on both ends. You have a cylinder at one end, not cylinder, an arch at one end, a semicircle at one end, and a linear element at the ground. Linear element at the ground. One linear element and a circular element. Use the same thing. This is the circle, this is a linear element. Only one circle, here it is linear. You just join them. So this point is in the ground plane. It is in the ground plane, and here the points are getting changed. So they will be inclined. First and the last will be parallel to the ground. All other lines will be inclined to the ground. Then if one point is a straight element and the other end is an arch, a curvilinear element, and if you connect them with the straight lines, you get a shape known as conoid, conoidal shell. Conoidal shell usually used for storing building materials. So you have an opening so that you can, or the materials can be put in. At the same time, it is not cylindrical totally, so that it can save space and the cost. You can remove the material also easily because you have a gap. But it will gradually go taper to the ground, a conoidal shell. Then, in the cost-effective appropriate technology, there are two important building technology methods. One is the cost-effective technology, or the low-cost technology, or no-waste technology. Another is the appropriate technology. The appropriate technology. So, another type of shell, in the case of appropriate technology, is called the funicular shell. Funicular shell. Funicular is a shape you get because of gravity. A shape which you get due to gravity. So, for example, this is a sack. Just to see that this is a sack. You pour concrete in this. If you just pour any material in this, the sack will take the shape according to gravity. It will take a shape when you put the concrete over this sack. When you lift it, first you put, then you just lift it. That shape is called a funicular shape. Then you allow that to cure for 28 days. Make it hard, set and hard. Then you just make it upside down. If you make it upside down, it will be just like a funicular shape. You have long shells and short shells. How the structural action we will see when we come to building technology. Now, architecturally, you have funicular shell, short shells, and long shells, funicular shells. Then, the architecture will have material character, manufactural or fabricational character, dimensional character. Then the character of color. Color will give a character. So the external finish using different pigments or paints, either with a single color or a dual color or even a multicolor, will give different visual feeling even though the structure is the same. If a column is painted white, a column is painted black, a column is alternatively painted with white and black, the character of the column, even though there is no change in the material, change in the form, but only the color has changed, by which the character, the visual feeling will get altered. Another character is the texture. Texture. Texture is defined as the feel of touch. Texture is defined as the feel of touch, and it is purely an external feeling. It's an external feeling. It doesn't convey anything about the internal character of the element, of the component, of the structural system. It gives you a feeling of touch, texture. You have smooth texture, soft texture, or hard texture, finish. Reflective texture or absorptive texture. Light texture or dark texture. You are getting what texture means. At that time, the structure is just different from this. The structure means the internal molecular arrangement of the element. So structure is the internal arrangement. Either it may be crystalline, or it may be amorphous, or it may be granular, or it may be layered, or it may be honeycombed. So structure is the internal particle arrangement and texture is the external appearance, which is known as the feel of touch. Thank you. God bless.